Welcome back to day 26 out of 50 on our journey to scoring a 750 or higher on SAT Math. Today we're going to be doing geometry and trigonometry questions, starting with this first one, which is a volume question. What is the volume in cubic centimeters of a right rectangular prism that has a length of 4 centimeters, a width of 9 centimeters, and a height of 10 centimeters? So we know our volume for a cubic or for a right rectangular prism is going to be length times width times height. So plugging in, we have a length of 4, a length of 9, or a width of 9, and a height of 10. And that's going to give you 360 cubic centimeters, but you don't have to worry about the units here. It's just 360. The circle above has center O. The length of arc ADC is 5 pi and x is equal to 100. What is the length of arc ABC? Okay, so it tells us this angle right here, or this arc, is of length 5 pi. And we know that x is equal to 100. I'm not going to write that down because it won't fit in there, but yeah. So we can set up kind of this ratio where 100 degrees over 360 degrees is equal to the circumference length 5 pi over the total circumference c. And we can solve this by setting the equation equal to c. And what we're going to do is c is equal to 5 pi times 360 over 100. And that's going to give us, when we use our calculator, we get 18 pi. So if our total circumference is 18 pi, we know that the length of arc ABC, which is this over here, is going to be the total circumference, 18 pi, minus 5 pi, which is equal to 13 pi. And that's because the only remaining arc length is 13 pi after we subtract the 5 pi. So that's going to give us an answer of B. Okay. Next question. Triangle ABC is similar to triangle XYZ, where A, B, and C correspond to X, Y, and Z respectively. In triangle ABC, the length of line AB is 170, and the length of line BC is 100 or 850. In triangle XYZ, the length of line YZ is 60. What is the length of line XY? Okay, so a lot of letters. A lot of numbers. So we're going to start by drawing out our triangles. So we have this triangle over here, which is going to be a little smaller. Oh no, this one's going to be bigger, sorry. We're going to have a bigger triangle. And we're going to have a smaller triangle. Okay, this obviously isn't drawn to scale, but it's just for visualization purposes. So we have triangle A, B, C. And we have triangle X, Y, Z. It's important you label them the same. So if you do A, B, C here, it has to be X, Y, Z there. Now we're gonna label our length. So AB is 170. BC is 850. So obviously it's not to scale as you can see, but it's just for a little visualization. Line YZ is 60. Now it's asking what is the length of XY. So similar to the last problem, we're going to set up a ratio. We have that the ratio of line AB over line BC is going to be equal to line XY over line YZ. And now we're going to plug in our points. I hope this makes sense. This is just that this length over this length is going to be equal to this length over that length. And it's because this little fact right here, triangle ABC, is similar to triangle XYZ. That allows us to set up this ratio. So now plugging in, we're going to get 170 over 850 is equal to an unknown. We're just going to call it X over 60. And now we simplify this using our calculator. So we get X is equal to 170 over 850 times 60, which gives us times 60 divided by 850, 12. So what is the length of xy? Well, that's going to be equal to 12, since x is our xy. We just set it as a variable. Well, if this makes it any clearer, you could just leave it as this, and it would be the same deal. So 12. Okay. Looking at the last question for today. In the figure, RT is equal to TU. The measure of angle VST is 29 degrees, and the measure of angle RVS is 41 degrees. What is the value of V? Okay, of X, sorry. So we are going to fill in our angles. Angle VST is VST, so that's going to be this angle over here, and it's going to be 29 degrees. And then RVS, so our angle right here is going to be 41 degrees. So we know that since line RT and TU are equal, we have RT and TU equal. These angles are also going to be equal. So whatever this angle is also this angle. Okay, so now we have to fill in some angles to solve. So when I see a bunch of triangles over triangles in this problem, I try and look back for a second, and I see this is the triangle that's most obvious. But then if we look back, we see this triangle over here too. So we know that these three angles are going to equal 180. So if we find this angle right here, we can find that angle. So using our supplementary angle rule, we can solve for this right here. And 180 minus 41 is equal to 139 degrees. So 139 degrees is going to be this angle. And now we know this angle, and that angle. And we know our triangle angles add up to 180 degrees. So 180 minus 139 minus 29 is going to give us an angle of 12 degrees. So that's going to be our angle for this remaining one right here. And we know that this angle is going to be equal to this, as we said before. So that's also going to be 12 degrees. And now we're solving for x, and we just do the same thing we did for the first one. We have two angles, one unknown, and a triangle. So we know that they add up to 180 again. So 180 minus 12 is going to give us 180 minus 24, which is equal to 156 degrees. This is going to be our angle for x. So you're going to input 156 into the computer. Don't worry about the degree symbol. This is a hard problem, as you can see. A lot of, little facts to deal with. Know your supplementary angles, know your angles of a triangle rule, and you should be good. I'm going to leave it off here for today. And if it helped, please subscribe to the channel. And please, in the comments, leave any suggestions that you have for any future videos. We can always mix it up a little if you guys want. And yeah, I'll see you guys on day 27.